morning everyone, I'm Elvin Kagampang and together with my partner Miss Manilyn Umbod, we are going to discuss about implicit differentiation. First, we are going to talk about the lesson objective of this topic. So the lesson objective is we are going to differentiate a function defined implicitly. So to begin with our discussion, Miss Manilyn will continue to discuss what is implicit differentiation and other examples.
So, what is implicit differentiation? Implicit differentiation is a process of finding the derivative of a dependent variable in an implicit function. A function with respect to x, we need the concept of chain rule. So, these are the derivative notations. The first is f prime of x, then y prime, du over dx, and dy over dx. So, our examples. Example number 1. F of x is equals to x to the power of 5. So, we will find the derivative of the function x to the power of 5. So, f prime of x is equals to derivative of x to the power of 5 in terms of x. In this function, we will use the power rule. Power rule states that if f of x is equals to x to the power of n, then f prime of x is equals to nx to the power of n minus 1. It became f prime of x is equals to 5x to the power of 5 minus 1. And 5 minus 1 is 4. So, the derivative of the function x to the power of 5 is f prime of x is equals to 5x to the power of 4. To see that you may also write here dx over dx. But pwede ring wala na kasi dx over dx is equals to 1. So, pwede ring the answer would be f prime of x is equals to 5x to the power of 4 dx over dx. Pwede ring wala na kasi dx over dx is equal to 1. So, this type of derivative is derivative in terms of the same variable. Kasi, isa lang variable ang nakikita natin in this function. Example number 4. X squared plus 6xy plus 5y squared minus 4x equals 10. To find the derivative of this function, we will first, let's differentiate each terms with respect to x. In our first term, we will use the power rule. So, 2x to the power of 2 minus 1. Then, to our second term, 6x y. Since our second term has the two variable which is the x and y, we will use to solve for the derivative, we will use the product rule of differentiation, which states that if f of x and g of x are differentiable differentiable functions, then the derivative of f of x times g of x is equals to f prime of x times gx plus g prime of x times f of x, or let u be our f of x and our v be our g of x. Then the derivative of uv is equals to u times the derivative of v plus v times the derivative of u. To simplify this, u v prime is equals to copy the first, which is the u times the derivative of v plus copy the second, which is the v times the derivative of u. So, we will let our 6x be our u and our y be our v. So, copy the first, which is 6x times 1 times 1, which is the derivative of y is 1 times dy over dx plus copy the second, which is the y, then times 6, and the derivative of x is 1. So we already solved the derivative of our second term. Let's proceed to our third term. In our third term, we will use the power rule. So 5 times 2y to the power of 2 minus 1 times dy over dx. Then proceed to our fourth term, minus 4 times the derivative of x, which is 1, equals to 0, because the derivative of 10 is equal to 0. Our next step is to simplify this. So 2x to the power of 2 minus 1 is equals to 2x plus 6x times 1 is equals to 6x times dy over dx plus y times 6 times 1 is equals to 6y plus 5 times 2 is equals to 10, and 2 minus 1 is equals to 1. That will become 10y times dy over dx minus 4 is equals to 0. Then, let's isolate. Then, isolate the term with dy over dx on the left side. Since, so, 6x times dy over dx plus 10y times dy over dx equals to, let's transpose positive 2x to the right side, and it will become negative 2, and positive 6x to the right side, it will become negative 6y, and negative 4 would become positive 4. So, negative 2x minus 6y plus 4. Then dy over dx times 6x plus 10y is equals to negative 2x minus 6y plus 4, then divided by both sides by 6x plus 10y. Then cancel. So the derivative of this function is negative 2x minus 6y plus 4 over 6x plus 10y.
So once again, I'm Melvin Kagampang and I'm going to discuss to you about this, how to use these derivatives of trigonometric functions. Important terms that we need to remember in trigonometric functions. By the way, I forgot something. Diba here we have negative cos. So this cos will become sen. So that is how we solve the trigonometric functions in derivatives of trigonometric function.